Hello and welcome back to the lab. Today on the bench we have a 465 non-B this time, but it's another 400 series scope. I just grabbed one out of the pile and tossed it up here on the bench for repair. I have the scope plugged into the Variac and isolation transformer. Haven't even fired this up yet. The power pin is out. I'm monitoring the current draw, but there's no voltage applied to the scope just yet. A couple of the differences between the 465B and the 465. So the 465 non-B is also a 100 megahertz scope. There's a two-position potentiometer here, double stacked, as opposed to being in one control. So that's a little different to get used to. This one, the B delay trigger has been absolutely smashed. The control's still working, but this is going to need to be addressed. The other thing is, we have, and I don't know if it has to do with this scope's history and who it was made for, but we do have, looks like Tech made this for Burroughs, possibly. Have to look up and see what they did. Intensity needs to come down for sure. That was way up. Let's see here. Overall, the scope's in good condition. A little dusty, needs some cleaning. The controls are a little crunchy, but that's nothing that a good cleaning won't help out with. The 465B very easily hit its 100 megahertz bandwidth. The 465s, they did kind of struggle to get there. The 465s were all discrete, where the 465Bs started to use ICs and were much better at high speed. But it still works and is well worth fixing. So we'll give it some voltage, see if it wakes up. So it's a little light in wattage. At 50 volts RMS, it's drawing about 3 watts. So some of it's there. Not shorted, that's for sure, because I don't see current going through the roof. But at 121 volts, 21 watts, and we have no lights. So at least some of the power rails are missing and need to be repaired. So first things first, as always with these, power supply troubleshooting. Let's check the rails, make sure there aren't any shorts. All right, on first inspection, we have a very early version of a 465, tagged tantalum capacitors. Don't necessarily know what happened here. That's going to need to be addressed. Really, really early, very early example of tuning capacitors. So we have a very early version of a 465. Serial number on this one is 21 and some change. 21746. So definitely going to need some cleaning. Going to need some TLC to get up and running. But first off, we're going to fix the obvious, check the power supply. Then we'll get into our usual restoration process. So I was setting up to do some voltage injection just to see if I could heat up the part in question, but my thermal camera's dead, so... Oh, well, that's terrible. Yeah, we'll put this on high so it doesn't flicker. Sorry about that. But if we take a look at this right here, that little silver orb, that is tantalum metal that is leaking out of this capacitor, so we at least have one dead tant right here. So we had a tantrum cap throw a tantrum. That's not a surprise. And what we were looking for. All right, that was a short. I checked the capacitor and it was very open. Or, I'm sorry, very shorted. And let's see if it is the short. I now have 151 ohms on my 15 volt rail, so that might have been the short. Let's give it some power and see what happens. All right, I've got about 50 volts AC on the front, or on the line side. I'm not expecting anything to happen quite yet, but let's see what we're looking like. I've got voltage, 1.9, negative 8 rail. Negative 8 rail may not be awake yet. That's going to be plus 55. That's got 23 volts on it. Plus 5. Yeah, we're okay. So let's give it some more and see if it wakes up. Let me reposition this so you guys can see what's happening. All right, so the cap that I pulled out looked like just a bypass cap based on where it was in circuit. So not too worried about it. But let's see if we give it. Well, that's up. There's sweep. All right. Well. Oh, whoa. That was bad. Okay, that's a problem. Pulled it way down quick. So there is an issue in the high voltage section. Actually, let me turn on the 10x magnifier, make it go as fast as it can so we don't torture out the tube. Oh yeah, we have lots of high voltage problems. So I don't really have control. I do have some control over intensity. But I don't have a lot of control over focus. Gradical illumination can come down. So we are going to have some fun on this one. This has got HV problems. Because if I bring it all the way up, it's just going to get brighter and brighter and brighter. Yeah. All right, so that is usually the DC restorer diode, or that's at least one of the common problems in the HV supply is the restorer diode, and it's getting AC from the high voltage transformer into the tube circuit. So let's check that. The DC restorer diode cannot be checked. First off, we're going to dive into the high voltage section, so if you're following along, you are doing so at your own risk. Please take care. There is extremely elevated voltages in there. Secondly, the DC restorer diode has a V-forward of, if I remember correctly, about 100 volts, so it cannot be checked on a normal DMM. You have to use a curve tracer to check that. I do have a curve tracer available here to me in the lab. And I hope it is just the DC restorer diode, because that will not be a problem. But scope's got a brain, sweep's working. Obviously the attenuators need to be cleaned. But this is looking really good. Alrighty, I have the new DC restorer diodes in. The old ones are here in the dish of shame, or broken parts, whichever. And let's see if that brought our trace brightness control back. What I'm looking for right now is just to have brightness control. I know there's still some issues, like this control shattered, things like that we have to fix with the scope. So it's not done quite yet, and I haven't cleaned any of the attenuators or anything like that. So just looking for brightness control at this point. And it helps when I plug the scope in. Yes, it does help when I plug the scope in. All right, here we go. I heard the high voltage start. Did not get any flash over on the high voltage, so that's good. Hey, there we go. All right, so DC restorer diodes were the problem there. That control's a little dirty. Need to clean that a bit. Not a problem. But, so we've made great improvements already because we have brightness control back. So now we can work on troubleshooting the rest of the scope without torturing the tube. Okay, as I was waiting on some glue up for some controls, which I managed to get repaired, I started doing some basic troubleshooting of the scope, figuring out what was going on. and trying to figure out if the scope had a brain, and if so, how much of a brain, and if we had any other troubleshooting that needed to be doing. The good news is the vertical section was actually running just fine, but this scope has a triggering problem. So I started doing some troubleshooting in the triggering section. To catch you guys up to speed, our trigger amplifier ICs, this is the B trigger. This is the B trigger. The A trigger is actually hiding under the trigger view board. Trigger view board came in to assisted me with the troubleshooting process. I'm not getting triggering on anything, so it won't trigger on line, it won't trigger on channel 1, channel 2, nothing. It's just out to lunch. So I started poking around in the A trigger, and I noticed that if I hit trigger view, the board just showed DC. There was no, I had a square wave going into the front end. There was no square wave on the trigger view, which means I wasn't getting trigger to the triggering IC. Okay, let's start the troubleshooting process. Channel 1's trigger input is over here. I did have square wave here, so that's not necessarily a problem. The next thing is it goes into a switch pack, which is on the bottom side of this board. And then we come through this resistor into these two thermally coupled transistors, and then these pop out. It actually the trigger signal actually pops out right here at this resistor and flows into the trigger IC. So I didn't have any signal here. So checking the transistor, no signal. Coming backwards, no signal. Pops into this resistor, no signal, no trigger signal. So we're losing this trigger signal in this switch pack. I'm expecting just dirty switches and everything, which is common for this gear. So we're really going to have to. The problem is getting to this one without digging. I'm probably going to have to dig this board out and actually service these like I should. But that is going to require removal of the trigger board because the shield for the timing board is in the way. But if we're going to dig that far into the scope, we might as well pull the timing board out too. Not pull the timing board out, but uncover the timing board and clean up those switches as well. So I'm pretty sure I'm losing the signal in this switch pack, so these switches are dirty and need cleaning. The reason that I also believe that is when I had the scope probe hooked up to this resistor, I had enough amplification where just the noise from the scope probe was causing the scope to go into triggering mode. So the trigger circuit and the trigger amplifier and the trigger detector is all working like it's supposed to. The signal's just not getting from point A to point B. It's always electrical mechanical. And after a bit of extraction, here is the trigger board. It's actually backwards. Switches are over here, so they should sit on this side. Trigger view, we have controls, a couple of jacks on the front needed to be unsoldered. The potentiometer for a hold-off needed to be unsoldered. That was way down here on the board. But we've got it out, and now it's time to clean the switches correctly. Okay, I've got the trigger board back in, as you guys can see. Gonna fire this thing back up. No smoke, survey says. I didn't hear any snaps or cracks or anything stupid like that. So that was good. All right. And we have a trigger. All right, so contact cleaner for the win. And I'm also not full of it. Actually, the amplitude looks really nice on that, too. This might actually be in pretty good calibration. We'll have to check some timing and a couple of other things, but yeah, that's off by, let's see, I got it on 0.5. We'll bring this down. Yeah, that looks about right. I had 1.5%, so not too bad for a scope that I haven't aligned or calibrated yet. So 1.5%, I am completely happy with that. There'll be more checks that are needed. We did have some, I don't know how well the camera's going to pick this up, but we did have some crap come out of the switches. So definitely needed some cleaning there. One thing about contact cleaner is you'll have contact cleaners. I'm not sponsored. This is just a contact cleaner. But if you look, there's some sitting up here in the rim, and this can, for whatever reason, it stays there. This can is not rusting or anything like that. If you have any contact cleaner where it's showing rust on the can, where the liquid's been sitting or after use went away, it's way too aggressive for anything electronics, because it's going to do that to the contacts that you're trying to clean up. So any can that's rusting on contact cleaner, get rid of it. It's way too highly aggressive and should not be used. I'm sure there's interest there on cleaning methods and contact cleaners and things like that. I might do a video on that in the future. Not 100% sure, but I use a number of solvents, oils, lubricants, cleaners in the lab in all of these repairs. So there's a lot that will go into that video. We are now at the point, since I had to do trigger troubleshooting, that I can look at the power supply. I haven't even tested the power supplies yet for stability, things like that. I'm going to let this sit, let this burn in for a little while, and then we're going to check the supplies for voltage and ripple. Realistically, this is looking very, very good on the display. I'm relatively confident the supplies are going to be fine, but the scope does need to stay on for a little while so we can actually get a good reading as to how that looks and what's going on there. So for now, I'm going to let this burn in on the bench. Easiest way to do that is shove some signal of some sort into the scope to keep it triggered. This is as good enough as any. Sometimes I'll do a sine wave of some sort. And we'll just let this burn in. That's just a 50 kilohertz sine wave out of one of the calibrators. The whole thing, as I walk by, things like that, I want to make sure this trigger light stays on. So that's what I'm looking for. Looking for the scope to behave, not smoke out. Obviously, we keep an eye on it down here. But I don't want the smoke, or I don't want the scope to smoke out. And I also want to make sure it stays triggered, and every once in a while as I walk by, I'll bring the brightness up, just kind of look at it, see how it's going. And as long as everything behaves and the power supplies check in, this thing will be ready for an alignment, although it's pretty good as it is, at least from an amplitude standpoint. Okay, quick look while we're waiting on the 465 to do its thing on the circuit in question. Now, keeping in mind, we weren't getting any triggering at all. We weren't getting B triggering. We weren't getting A triggering. Nothing. Nothing was getting through. So I checked R623. This goes right into the custom tech IC for the trigger amp, and I didn't have any trigger signal here. So we came up, checked the base of Q22, which is actually R100, and still no trigger signal. Nothing at R100, and that was at any switch position, so nothing really mattered. So DC, AC coupled didn't really matter, and that fed back into this switch pack, and this switch pack right here is actually these two switches right here. So that's what led me to, and we know we had signal at the front side of those switches. We know we didn't have signal on the back side of those switches, so I have to be losing it in the switches. So, hence what led me down the troubleshooting path of cleaning up the switches. And indeed, we get a triggered light, and everything is happy. Well, I'm extremely happy with that. For those just finding this channel, these are time marks. This is going to check the accuracy of the time base. And essentially, right there, so the time base is off by 0.3% on 1 millisecond time marks. I am extremely happy with that given the age of the scope and everything else. So spot checks, at least for major functionality, major functionality, amplitude and sweep speed, absolutely fine. There's nothing wrong here now that we got it happy with triggering. The spec on these scopes is 3%, so 0.3 on a rubidium stabilized source is wonderfully accurate for a scope of this era. No problems there. All right, I'm doing this a bit out of order. The checking the compensation of the scope probe, and it looks okay. But I'm going to check the rise time of the channels, and we'll see. Nope, I got to go down one more and then variable it down. I need to get this down to the bottom, and I just don't have enough with a 10x probe. Checking this with a 10x probe is necessary due to that's the way these scopes are aligned. You can get better with a 50 ohms if you do the alignment with a 50 ohm terminator. However, not having a 50 ohm terminator gets you the best frequency response with the scope probes. Usually these are tuned with scope probes, not with the 50 ohm, which is one of the reasons why the switchable scope inputs, unlike the 485 and then the 7000 series with the 50 ohm inputs, if you're working in 50 ohm systems, well, one is you're working on stuff that's faster than 100 megahertz usually, and using those gets you better signal because it's 50 ohm into 50 ohm. So now, what we do to measure the rise time, crank up the speed, probably crank up the frequency as well on the generator, crank up the speed, and 10x this out. And there we go. Turn on some high frequency or low frequency rejection. And there's some step response. All right. Now we are pushing the scope absolutely to its limits. On this, we've got the 10x magnifier locked in, and we have plenty of brightness. So this tube is actually very, very healthy. But if I line up right here, then I take my measurement right there. Although the step response is a little light, but this could be probing. And a couple of other things. This is a very long cord on the probe. Oh, I just bumped. Yeah, there's some impedance, and that probe is kind of That's a much better step response. Yeah, there's some. There we go. That looks better. That was just on the jack, so the jack needs a bit of cleaning on the front end, which isn't a problem. But our 0 and 100 lines, and we are at... I don't have any more speed. This is a very nice, actually, step response. That's more about what I would be expecting, so my probe is a little weird. So let me get right on this, and we'll come right back. All right, so looking at this step response, it's a little shy of 0.8. So the way the math works out is so we'll call this 0.75, because it's just a bit shy of 0.8, maybe 0.775, into 50 microseconds or 50 nanoseconds per division. With a 10x magnifier, it takes down to 5 nanoseconds per division. So it puts our rise time right at about 3.8 or 3.75. Sorry, 3.5 nanoseconds. So with a rise time of 3.5 nanoseconds, we are at just shy of 1 megahertz, 99.999999999 to infinity. So the step response of the vertical amplifier is still good, and everything looks okay. So let's check power supplies. So buzzing through all the power supplies, they were in spec for DC, and all the power supplies had under a millivolt of ripple. Actually, all of them tested about 0.1 volts, or 100 microvolts of ripple on the supplies. So the DC supplies in this scope are very happy. I do need to fix that one capacitor. I haven't put that cap back in yet, so we'll power this down, go ahead and do that, and then I'll bring you guys back. And after the capacitor was replaced, I just tossed an electrolytic cap in there. That will be absolutely fine. Those tantalum caps were just bypass capacitors in the circuit and actually weren't even labeled on the service diagram. So I measured the power rail at 15 volts, so I put a 35 volt 10 mic cap on there, and that's going to last forever. So thanks for stopping by the lab, taking a look at the restoration on this 465. This scope has been not calibrated, but function checked for base functions, almost all of them. Frequency response is good, amplitude is good, timing is good. So this scope is in really, really, really good shape. If someone's interested in this scope, hit me up in an email. Maybe check out the webpage. I'm going to start listing some of this gear if anybody's interested. If you would like a full alignment done on the scope, let me know. We can talk about that. I'm not going to do a full alignment on this scope because I don't have a need for a 400 or a 100 megahertz scope. I have that covered extensively in the lab. But if someone's interested in a full alignment, we can talk about that. Those do take about 6 hours, so there's quite a bit of bench time to do one of those. So one of the reasons why I'm not going to do it on this one unless there's interest. With that, as always, thanks to all the patrons who help me keep videos coming up to YouTube and keep the lights on here in the lab, as well as everybody who's stopped by and taken a look at a video. I read the comments in between every single video, and more is always on the way. So hit me up in the comments section or drop me a line. Love talking to everybody. The bad parts in this scope: one cap, 2 diodes, and that brought this 465 back up to operating. With that, I'll see everybody in the next video. As always, more is on the way.